Hey guys, let's go ahead and get into what we're going to be talking about today. So, we're going to continue to be looking at different scenarios that involve looking or creating and analyzing box and whisker plots to kind of compare how two different sets of data compare to each other. So, again, guys, some of us have found tools that have allowed us to create box and whisker plots on our sheets that we've been working on. But several still haven't. Therefore, I'm going to be pretty lenient on questions that we go over that talk about box and whisker plots or box plots. Same thing. So I'll create the box and whisker plots on my page. If you can make them show up on your page, then that's fine. But don't worry too much if you can't. So, guys, I think today's lesson is going to be a pretty good one. I like it because it gets some pretty interesting data represented. So the page that we're going to be looking at today, it'll be again on Google Classroom, but it's looking like this, and it's showing different speeds, or it says exercise 6 through 10, maximum speeds. And what it's talking about on this page is it says the maximum speeds of selected birds and land animals are given in the tables below. So what they did is they went on the Natural History magazine, which, again, this is a fairly old resource, 1974. But that being said, you're probably not going to expect land animals' speed to change too drastically, or birds' speed to change too drastically in that many years, simply because they're still going to be that same kind of bird or that same kind of animal. They're still probably going to run, at least very close to the numbers they give us in this data. That being said, it probably would have been more useful for them to give us a more recent resource. But again, it's okay if some of these numbers are a little outdated at this point, because the point will still be made when we analyze these questions. So what they did on this resource is they went through various land animals like pigs, jackrabbits, lions, and then they went through various birds, ostrich, pigeon, spine-tailed swift, just different types of those. And they found, at least on some of them, they found some of the fastest ones they could find. On other ones, they probably were trying to find slower ones on purpose. But let's just take a look and see what we got here. So on exercise 6, it says, as you look at the speeds, what strikes you as interesting? So in other words, if you're looking at that table, either the birds or the land animals, take a second, again, pause the video if you need to, and look at numbers and see which animals or birds might stick out to you. So take a second to look at that. And that could be either super fast, super slow, maybe one is faster than you expected, maybe one is slower, stuff like that. So when I look at this, I would say I had a few things, and there's several you could honestly put down. I think the first thing I say is going to be the one that probably most people would say that looked through these and found something. I said that the peregrine falcon is very fast. If you look at the peregrine falcon, first off, there's some pretty fast birds here. They're miles per hour. There's several that are 100 or more. But take a look at the peregrine falcon. If you look at the peregrine falcon, not only is it the fastest one, but look at the difference between it and the one below it. At 120, it's way up there at 242. It goes 242 miles an hour compared to the rest of these birds here. And what makes it even more significant is if you look at the other ones, they stay pretty close, 80s up into the 90s. 100, 105, 106, 120. Those are staying relatively close, within 10 or 15 at least each time, sometimes even less than that. But then it doubles. It goes up by over 120 from one species of bird to the next. Now, I'm not sure if they've looked at all the fast species of birds. But if they have, then the peregrine falcon is way faster than any other bird out there. Now, I'm sure they missed a few here or there, or maybe they were just trying to find one significantly faster than the other. I'm not totally sure, but the point of it is 242 miles an hour is extremely fast. And guys, just to kind of put this in perspective here, at least a few years ago, when they were looking at average speeds of humans, the fastest, and we're talking about just the fast. And as we know, the speed of humans can fluctuate a lot. Some people aren't very fast. Some people are kind of fast. Some people are very fast, which is why they make the Olympics or professional sports. But from what I've researched, the fastest human, I want to say, clocked in at around 24 miles an hour, something like that, between 22 to 24 miles an hour. And that's fast for a human. But think about that, 22 to 24 miles an hour versus 242 miles an hour. That's extremely fast compared to us humans. I mean, we wouldn't be close to being able to keep up with that. So that just kind of gives us a little bit of perspective here. So also, another thing I've looked at and just kind of looking at these tables, the birds, first off, this is interesting. The ostrich is technically the slowest bird on this table, but it's still way faster than a human. It can go up to 60 miles an hour, but the range here goes all the way from 60 all the way to 242. But then when I look at the land animals, they got a pretty slow one here. Pig, slower than a human. Human could run a pig down. But it goes from 9 up to 75. Now, if you are not excluding or taking away any numbers on this table, and you look at how spread out the numbers for the birds get to the numbers for the animals, it appears that the birds have more variability than the animals just because their numbers end up getting more spread out if you're just taking into account how far apart the biggest and smallest numbers are. So the other idea I said on this, as I said that the spread for the birds is a lot more than the animals. When you think about the birds, if you're going from 60 to 242, that's almost a range of 200. That's like a range of 182. But if you're looking at the land animals, they go from 9 to 75, which is about a range of 66. Should be a range of 66. Now, and while that might seem like a fairly big range, which I would say it's a pretty big range considering the data, it's nowhere near as big as the range for the birds. So that's why I said that the spread, how spread out they are, is for the birds is a lot more than the animals. And I went ahead and said another idea. Since I noticed that the peregrine falcon was very fast, I also thought about the one that's very slow. So take a look at the table for a second and think about which one is probably, out of both tables, which one is probably going to be considered very slow. Well, I would have to say it's the pig. The pig, if we're basing it on the idea that humans can run somewhere in the 20s, low to mid 20s for top speed, the fastest of them at least. The pig is the only one that could get run down by a human. So I went ahead and said that the pig is really slow because it can only go 9 miles an hour. That's not too fast. Most humans, even if they're slower, could run down that. So those are the 3 points I had. I said the pig is really slow, the peregrine falcon is very fast, and the spread for the is a lot more than the animals. So feel free to pause and write these down if you need to. But those are the points I put on number 6. Okay. So then they asked, do birds or land animals seem to have the greatest variability in speeds? Explain your reasoning. Well, there's a couple thoughts here. First, I've already kind of talked about this. When we're talking about variability, typically it's how stretched out data is. Now, I pretty much have already explained it, so I'll just kind of show it here. I said the birds seem to have more variability because they go from, that says 60 to 242 than the animals do, which they only range from 9 miles an hour to 75 miles an hour. So this range of 60 miles an hour to 242 miles an hour would be more spread out, so most likely going to give you more variability than the animals going from 9 to 75. Now, one idea to think about, guys, is, which we'll kind of get into a little bit later, but think about something. We've talked about this a little bit, but when you have outliers, which we've talked about, outliers are simply looking at a number and saying that does not really go along with what this table is showing. And typically, the easiest way to spot an outlier is when you see numbers kind of gradually changing about the same, and then you see one just make a big jump, either bigger or smaller than a number. So if I look at the birds, honestly, do you see a number that you might consider that's an outlier, a number that kind of jumps way up or way down that probably, if you're trying to get consistent data, probably really doesn't fit? Well, I would have to say it's the peregrine falcon, because if you look at the peregrine falcon, like we already said, it makes a huge jump from 120 up to 242. And if you look at the rest of these, they increase fairly at a fairly consistent rate. I mean, they're going from 60s to 70s, 80s, 90s, 100s, 120, a little bit more of a jump, but that's a huge jump. So if you had decided to say that the outlier might have been the peregrine falcon, you really, if you look at the variability, if you didn't count the peregrine falcon, the variability on the birds, the spread only goes 60 to 120, which is only a spread of 60. So if you did not count the peregrine falcon, they actually both have a very close amount of variability in them. But we're going to go ahead and count the peregrine falcon on here, and we're going to go ahead and say that the birds do have more variability than the land animals. So you don't have to change what I wrote on there. You can keep that the same. But just keep that in mind. If you decided to consider the peregrine falcon to be an outlier, that would actually make it where they almost have the same variability if you're just considering spread. Okay? So on to the back. So we're going to talk about 8 through 10, and then we'll be ready for our assignment. On 8 through 10, when we're looking at this, again, we're going right back to ideas we've already done here, guys. We are just taking what we've learned from the last couple of days, and we're going to just kind of practice some more until we all have a decent idea of what's going on. Just because what I've seen on some of the assignments turned in is I think we're understanding median, minimum, and maximum pretty well, but some of us are still struggling with Q1 and Q3. And guys, just keep in mind, they're not too complicated, Q1 and Q3. Remember, Q1 is the lower quartile, and all you have to do on Q1 is look at the lower half of your numbers. So if you listed a list of numbers from biggest to smallest, cut them in half, make it a lower half and an upper half. If you look at that lower half of the numbers, like for instance, if I had 10 numbers in a list, the lower half would get 5 of those numbers and the upper half would get 5 of those numbers, right? Well, if you want Q1, look at the smaller 5 numbers and find the middle of it. And that's Q1. And then if you want Q3, look at the bigger 5 numbers in your list and find the middle of those, and you found Q3. So don't overthink it, guys. These aren't too complicated. I'm confident that you can figure these out. So it says on number 8, find the 5-number summary for the speeds in each data set. That means they want you to find all 5 for the birds and all 5 for the land animals. So then it'll ask you a question later that we'll go over in a second. But guys, just to kind of save the little math here, and please, I would highly recommend you to try to find these out too on your own. And when you find them, check my answers on his video and see if you get the same ones. But here's what I did when I analyzed the data. First off, on the birds, here's what I got for the birds. I'll put it right here, trying to kind of make it where we only have one thing at a time. So on birds, I had a minimum of 60. That was the ostrich. The maximum was 242 for the peregrine falcon. I ended up getting, looks like a Q1 of 76. So the middle of the lower half of my data was 76. Median was 97.5. So there ended up being two numbers in the middle on median. I had to take the average. I think it was 195 were in the middle. And then Q3, 105.5. So again, since there's a 0.5, that means there's most likely two numbers in the middle on Q3. Those are the numbers I got on birds. Okay. Then if I look and focus on animals, and don't worry about this part up here just yet. On animals, look at the minimum was 9, which is the pig. Maximum was 75, which is the cheetah. And we'll talk about something about the cheetah in just a second here. I think you'll find interesting. So minimum 9, maximum 75. I ended up getting, looks like a Q3 of 32, or sorry, Q1 of 32.5. My median was 43.97, which again, that should have been the horse. We'll talk about that in just a second too. And then my Q3 looks like it was at 50. Okay. So those are the ones for birds and animals. So a couple thoughts. First off, if you think about the cheetah, cheetah is an interesting animal. It's known as the fastest land animal on the planet. Now think about that, 75 miles an hour. So I read an article several years ago that talked about a guy who was, if I remember correctly, he was like riding on a motorcycle across like in Africa or something like that, riding, like driving across the plains. Now, why he was doing that, I don't really know. But what happened was, I guess it was a wild cheetah. He ends up noticing him and just runs after him. And he just riding along on his motorcycle about 60 miles an hour. And he looks to his right and he just sees a cheetah right alongside him, same speed as him. Could you imagine going that fast? And you look to your right and you see something like a cheetah right beside you, just keeping up with you while running. But it had to be probably a fairly terrifying experience. But it just goes to show how fast cheetahs can be. And that's not even a cheetah could have run faster if he wanted to, because the cheetah has top speed at 75 miles an hour. Now, one thing that is like a disadvantage to cheetahs, though, that kind of gives some other animals advantages. Because if you think about it, you could think, oh, well, the cheetah could run down anything that it wanted to if it was trying to catch it. Well, cheetahs aren't known for having good endurance, so they can't run that far, that long. So they can run really fast, but they can't hold on to that speed very long because they end up basically getting winded from what I've read about them too. Now, the other thing about horses, 43.97 miles an hour for horses. What I found interesting about that is they got really specific on that. If you look at those tables, and they actually did it for the hummingbird too, which I found interesting. All these other ones ones for animals are just whole number, but they end up getting really specific for some reason on the horse than they do anything else. And then they do the same thing on the hummingbird over here. Everything else had a whole number, but the hummingbird, 61.06. So I don't really know why they did that, but just an interesting thought. So anyway, those are the 5 number summaries for those. And then they asked another question on number 8. It says, what do the 5 number summaries tell you about the distribution of speeds for each data set? Well, a couple ideas. I said one idea here, and I said that the 5 number summary can help tell you how spread out each section of the data set is. So when I say that, I mean, okay, when you think about knowing what the minimum, maximum, Q1, median, and Q3 are, each one of those is a piece of the box plot. It tells you like the gap between the minimum and Q1. It tells you about the gap between Q1 and the median. It tells you about the gap between median and Q3, and it tells you about the gap between Q3 and the maximum. Well, if you think about it, that means that the gap between the minimum and Q1 goes from 60 to 76, so that gap is 16 apart. And then Q1 to the median goes from 76 to 97.5. That's about 21 and a half apart. And then the median to Q3 gets closer together. So that 1/4 of the numbers gets closer together because it's only from 97.5 to 105.5. That's only a difference of 8. So it gets closer together on the next 1/4 of your numbers. And then from Q3 to the maximum, huge spread. It goes from 105.5 on the birds to 242. That's over 100. That's about 100 and I don't know, about 136 and a half, something like that. So pretty big difference there. So that's the kind of idea I'm getting at. Each piece of the 5-number summary tells you how spread out each part of your data is. If you're basing it on the quarters of numbers that we've talked about that a box plot does. A box plot breaks data into quarters. So basically you can say, better way to say it is it tells you how spread out your quarters are, the quarters of data are. But I just went ahead and said it shows how spread out each section of the data set is. That's what I'm getting at when I say that. Again, so if you need a little clarification, that's what I mean when I say that sentence. Talking about how spread out you are from each section of your box plot. So number 9, again, if you can make this work on your paper, go ahead and try it. But again, I know we're limited on our resources here. So number 9 says use the 5-number summaries to make a box plot for each of the 2 data sets. So if you're able to, make a box plot for the maximum speeds of the birds and make a box plot for the maximum speed of the land animals. So I went ahead and just did it here. And again, if you know the 5-number summaries, guys, box plots are simple because all box plots do are all you do to make them is just label the 5 parts of the 5-number summary. You label the minimum, Q1, median, Q3, and the maximum. And you just make a box plot out of them. So I'm going to go ahead and show you one at a time. So the bird one is going to look pretty interesting here. So birds, first off, and sorry about the angle here, making this look a little off, but the median, and I was just estimating here, honestly, I probably could have moved this over a little more. Not the median. The minimum was 60. Q1 we decided was 76, so a little bit past 75. Median was 97.5, so it's just a little bit before 100. And then Q3 is 105.5, which should be a little bit past 100. And sorry if it's kind of hard to see on the paper, but yeah, I'm just marking each one of these in my box plot. And remember, Q1, median, Q3. The maximum's 242, way over there. Now look at that. If you're looking at this box plot, that's what I'm getting at when I'm talking about that 242 for the peregrine falcon is a possible outlier. Because look what it does to this box plot. It makes this whisker so much bigger than anything else on this box plot. And honestly, if you remember, the second fastest bird was only at about 120, which would have made the whisker stop about right here. Think about how much difference that one bird made to this whisker, how much longer it made it. So it's kind of an idea I had on that one. So that's the one for the birds. As you can tell, because of the peregrine falcon, it got way more spread out for the birds than it did the land animals. So again, I put on the side that could be a possible outlier because it's extremely higher than the other numbers. It's a major difference between it and everything else on there. Okay, so let's take a look at the land animals. And again, just kind of estimating on here, guys. Again, I probably could have moved this over a little bit, but just kind of keep in mind we're just using the data we have. So for the pig, it's supposed to be at 9. Again, I would probably move it a little closer than I did to the 0. but over there about 9. Oh, wait, I'm sorry, guys. I'm totally misreading this. That's a 25. So, yeah, that's pretty close for 9. It's a little bit past halfway between 0 and 25. So, that's pretty accurate for 9 right there, at least if you're estimating. And then remember, if we're looking up at our 5-number summaries, our Q1 was 32.5. That'll be between 25 and 50, somewhere around the middle. Well, not really the middle, closer to 25. And then we decided that the median was the horse at 43.97, so a little bit in front of 50. And then we decided that Q3 was 50, so right on top of 50. And then our maximum was 75. The dot should be right on 75. It looks like it floated just a little bit, but that's okay. So the dot should be right on 75 for the maximum. Now, if I look at the 2 box plots again, this animal one looks way more spread out. Or sorry, this bird one looks way more spread out than the animals. But like I said, keep something in mind. If I had not counted this one, the box plot would have stopped about right here. If it did, this box plot would have been just about as spread out as the other one had if I stopped it right there. So keep that in mind. But again, you don't have to change anything. Just if you're following along with me, just write what I have. Then to finish off, and then we'll get into what we're doing for our assignment, it says, write several sentences describing the speeds of birds and land animals. So I wrote 3 sentences here. I'm just trying to describe the speeds of birds compared to land animals. So I went ahead and said a couple things, and we've really already talked about at least one of these. So first off, here's one idea, and I think it's a good idea to consider, especially when you're trying to analyze tables. First sentence I said was the fastest animal is slower than most of the birds. So remember what I said about the cheetah. The cheetah is the fastest land animal on the planet. Now, again, it'd be pretty terrifying if you're on a motorcycle and a cheetah can run beside you. But think about the tables we had on the first problem. The cheetah's up here at 75, but that 75 is slower than most of these numbers here. Looks like only 3 birds would be slower than that cheetah just on this table. So at least a majority of these birds are faster than the fastest one over here. And if you think about it, looking at some of the other ones, interestingly enough, the second fastest one was a bat, which some people may get confused about. You may think everything that flies is a bird, but a bat is a mammal because it has a type of fur, a type of hair on it, which makes it be considered a mammal. So keep that in mind. That's another interesting thought is the second fastest animal on this table is one that uses flight for speed. So it probably goes to show you that speed is most likely going to be utilized with flight when you're wanting a faster animal or creature on the planet, bird, whatnot. But again, if you don't count the bat, everything else on this table is faster than all these other animals. And even the bat is only as fast as the slowest bird over there. So that's one thing I thought of. Another thing I thought of, which we already talked about, is the animal data is showing less variability than the birds, which we already talked about. If you count the peregrine falcon, the birds' data is way more spread out than the land animals' data. And I'll show these in just a second. Okay, here's the last thought I had. I said the average land animal speed. So if I took the average speed for all the animals, which they didn't ask us to do here, keep in mind, but if I did want to know the average speed of those animals, I said it would most likely be much lower than the average for the birds, which I think would make sense, guys, because if we think about this, if I find the average speed of all these land animals, the data is fairly consistently spread out. So I would expect an average to be probably somewhere in the 40s, I would think. I haven't found it, so I really couldn't tell you. But I would expect an average somewhere in the 40s just because the data stays fairly consistently spread out. if I wanted the average speed for animals. But if I look at birds, think about this. If this, even if I go highball it and say the average should be closer to 50 for land animals, which it most likely wouldn't. It's probably going to be in the 40s. But even if it was close to 50, the lowest bird is 60 miles an hour. So if the lowest speed for birds is 60, there's no way it's going to have an average as low as the 40s. It's going to be higher, 60 or higher if the lowest one's 60. It's going to at least be higher than 60 because there's numbers bigger than 60 on there. So with that in mind, the average speed for the birds will be at least higher, if not much higher than the land animals. And it probably will be a lot higher than the land animals because if you consider the 242, that's going to it's going to most likely guarantee that the speed is at least an average of 100 miles an hour or more for the birds. So keep that in mind when you're thinking about average speed. Which is probably pretty obvious, guys, that the birds were going to have a higher average speed because most of them were faster than the animals anyway, right? So those are the three I said. Fastest animal is slower than most birds. On the first point, I said the average animal speed is most likely much lower than the average for birds. On the second one here. And then I said the animals data is, the animal data is showing less variability than the birds. Those are the three I said. So feel free to pause if you need that. So that's what we got for the notes today. So let's talk about what we're going to have for our assignment. And again, I think it'll be a pretty straightforward one, not too bad. We're going to skip one piece of this, guys, on this question. So it's one question that has 3 parts, but I only want you to answer 2 of them. So when I'm looking at this, it's I'm going to have one, and you'll have it on your Google Classroom page. But here it is. So here's your homework for Tuesday. They give you some different breeds of dogs. So the speeds for the fastest dogs are given in the table below. They give you different breeds, and they tell you how fast they are, and then some more breeds over here, and they tell you how fast they are. And what I want you to do here, guys, is there's an A, B, and C question. I want you to skip B. I will write this on your Google Classroom copy, but skip part B. You do not have to answer why is the median not in the center of the box. The reason you don't is, again, I don't want you to, if you can't create a box plot, you really can't answer part B. So keep in mind, same idea applies. On part A, it wants you to find the 5-number summary. Yes, find the 5-number summary. And at this point, I should not have to tell you what each part of the 5-number summary is. You should know it at this point. So find the 5-number summary like we've been doing. And we even found it a few times on the notes. And then it says on A, use it to create a box plot of the speeds. If you can do that, go for it. Again, I'm not holding it against you if you can't, just because of our limited resources right now for several of us. For those that can, thank you guys for doing that and going above and beyond. I have been giving you all bonus for that. So on A, keep in mind, you only have to find the 5-number summary on A. You don't have to make the box plot unless you particularly want to, just to keep it fair for everybody. On B, and again, on B, the reason you can't do B is unless you create a box plot, you really can't answer why the data is not why the median is not in the center. So that's why I really didn't worry too much about that one. So skip B. And honestly, C is going to be pretty simple. On C, it just says write a few sentences telling your friend about the speeds of the fastest dogs. Here's what I would say to do on C. On C, just tell me who the top 3 fastest dogs are. Let's just keep it simple. That one's not really hard, but it's just a little practice on if you can read tables. So just tell me the 3 fastest breeds of dogs on part C. So again, here's what the homework sheet should look like. It's just one question with, for us, 2 parts because we're skipping B. So keep that in mind. That's all we got for the homework. So guys, with that being said, that's all there is for today. Please message me if you have any questions. I'll be happy to help you. And if not, good luck and have a good rest of your day.